Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing KVPY 2019 SX Part 1 Mathematics, and the question for this video is this. Let there be a function f whose domain and codomain both are all real values, be a continuous function such that f of x square equal to f of x cube for all x belong to real. Consider the following statements. Statement 1, f is an odd function. Statement 2, f is an even function. Statement 3, f is differentiable everywhere. Then, four options we have to comment among these three statements, which all are true and which all are false. Let's solve it. Let's take x to be y to the power 1 by 3, let's say. So what I have is f of this, f of x cube would become f of y to the power 1 by 3 whole cube. So basically f of y equal to f of y to the power 2 by 3. Now again, since this holds for all x belong to real, so that means this will hold for all y belong to real. So that means I can replace y by, let's say, y to the power 2 by 3. So f of y to the power 2 by 3 becomes f of, so y ko y to the power 2 by 3 rakha. So here also y you put as y to the power 2 by 3 and whole to the power 2 by 3 is also present. So f of y to the power 2 by 3 is square. So again, f of y to the power 2 by 3 equal to f of y to the power 2 by 3 whole square. And mind it, f of y to the power 2 by 3 in turn is equal to f of y. Now again, if you put y to be, y to the power 2 by 3 again. So mind it, here let me write it f of y. Why? Because f of y is equal to f of y to the power 2 by 3 as per this first equation. And then, this also turning out to be equal to f of y to the power 2 by 3 whole square. So now f of y equal to f of y to the power 2 by 3 whole square. Again, let's put y to be y as y to the power 2 by 3. So this becomes f of y to the power 2 by 3 is equal to f of y to the power 2 by 3 square whole to the power, you may say, 2 by 3. My bad, as you put y as y to the power 2 by 3, so it becomes, f of y to the power 2 by 3 is equal to f of y to the power 2 by 3 whole to the power 2 by 3 square, which is f of y to the power 2 by 3 cube. So this will go on like this, yeah. So you may say f of, y is equal to limit n tending to infinity f of y to the power 2 by 3 whole to the power n. Now mind it, a 2 by 3 whole to the power n, as n tends to infinity, it becomes 0. So this power goes to 0. So that means y to the power 0 will be tending to 1. So that essentially means f of y equal to f of 1 for every y belong to real. Except when y is 0. Yeah, so for every y belong to real, when y is, let's say, not 0, based on the method we have used. Why? Because 0 to the power, anything which is not equal to 0 is 0 only. Because if y is equal to 0 and then you put power which is tending to 0, the overall value is 0 only. Why? Because base is equal to 0 and power is tending to 0. Yeah. So here, so for every y belong to real, but not 0 at this point of time at least, f of y equal to f of 1. Now what about f of 0? F of 0 has to be equal to f of 1 only. Why? Because f of x is given to us as continuous function. So if it is a continuous function, we can say f of 0 is equal to limit, you may say x tending to 0 f of x, or you may say limit y tending to 0 f of y. And f of y is equal to some constant value, some fixed value f of 1 for every y belong to real, except at this point of time, except 0. And that's what we are trying to comment upon f of 0. So around y equal to 0, f of y is not just tending to f of 1, but it is equal to f of 1. So, f of 0 will be equal to limit y tending to 0 f of y, because a function is continuous everywhere, and this turns out to be f of 1 only, because limit y tending to 0 f of y would be f of 1. So f of 0 equal to f of 1 also. So that essentially means f of x is a constant, and that constant is essentially f of 1 for every x belong to real. So that means it is a constant function. That means it is differentiable everywhere. Derivative would be 0. It is even function. Clearly, every constant function is an even function, because f of minus x is same as f of x, which is this constant c. It is not necessarily an odd function. It would be an odd function only and only if c becomes 0. That means fx becomes a 0 function, which is not necessarily so as per given condition. So that means 2 and 3 are short correct. 1 is not necessarily true. So D is the answer. Both 2 and 3 are true. Thanks for listening. Stay tuned for the next question.